Okay, hi guys. So in this lecture, we'll be seeing some of the examples of non-metals and metalloids that are reacting with HNO3. So let's get started. So we have boron reacting with HNO3, concentrated form at room temperature, forming S3BO3 plus evolving 3NO2. Then we have carbon reacting with 4HNO3, concentrated form at room temperature and forming S2CO3, which is just CO2 and H2O, liberating 4NO2 and forming H2O. Then we have P4 again reacting with 2HNO3, concentrated at room temperature and forming 4H3PO4 plus 2, this is P4, this is 20, forming 20NO2 and 4H2O. Okay, then we have S8 reacting with 48 molecules or moles of HNO3, concentrated at room temperature and forming 8H2SO4 plus liberating 48 NO2 and 16 H2O forming. Okay, next important reaction is, suppose we have X2, X being Cl, Br, I reacting with concentrated HNO3 at room temperature and forming 2HXO3, which is chloric acid, and 4NO2. Okay, just remember this important reaction. This is the reaction of halogens with concentrated HNO3. Next we have reaction of AS with HNO3. This is concentrated form again at room temperature, so we get HASO4, which is arsenic acid, and liberating 5NO2. Okay, then we have SB plus 5HNO3, concentrated form at room temperature, forming H3SbO4, which is antimonic acid, and forming 5NO2. Okay, with H2. Here also H2O, here also H2O. Okay, then we have an exception rule here. Tin with which reacts with 5HNO3, concentrated at room temperature, forms H4SnO4 plus 5NO2 plus H2O. Okay, this is stannic acid. So this further decomposes into H2SnO3 plus 4NO2 plus H2O, and this further gets converted to SnO2. So this is an exception rule. Okay, where acid breaks down into non-metal oxide. So this is exception, please remember it. So halogen acids have their ic form and their plus 5 oxidation state rather than plus 7. So here, as you can see, this is halogen acid, so these have plus 5 oxidation state rather than plus 7. Okay, next, if we another exception based on this only, that suppose we have Sn reacting with HNO3 dilute at room temperature, forming SNO plus NH4 NO3. Okay, so further, if it reacts with more HNO3 dilute, it forms SN NO3 whole twice. Remember this rule as well, or this reaction as well. Okay, this is also exception. Okay, so SNO and SNO2 both are amphoteric oxides. However, their reactivity towards acids and bases are different, and hence SNO, being more basic, forms SnNO3 whole twice salt, and SNO2 doesn't. Okay, so we can write here that SNO and SNO2 both are amphoteric oxides. However, their reactivity towards acids and bases are different, and hence SNO, being more basic, forms SnNO3 whole twice salt, and SNO2 doesn't. Okay, because this is more acidic. This is more acidic. Okay, so with this we come to the end of this lecture. In the next lecture we will be discussing more on the reaction of HNO3 with other compounds. So till then, good luck and goodbye.